In the following video, we're going to look at how we can import point clouds and compare them to models, whether they come from IFC or DWG, it doesn't really matter. But for this example, we'll be using IFC files. So what I'm going to do is I'm going to start a clean model. I'll just start a new normal model, just call this one IFC because that's where our data is going to come from just for now. And then I will view that and I'll go to the 3D view. Now I have the IFC in an Explorer view just off the side. Now if you wanted to, you could drag and drop that IFC into the view, but the problem is it will drag and drop it to where basically your mouse cursor is, and that might not be to the exact coordinates that you want. So if you want to use the coordinates in the actual IFC file, what you would do is you go to the 3D models and you choose import scene, and then it will import the file in the coordinate system that the file has, as opposed to where you just drop it into the view. So we'll do that. Okay, now that'll just take a second or two to come in. Okay, so that's now been imported. So we can see we have the 3D view with the data in it behind the Model Explorer here. So I'm just going to turn off the label. Okay, and here is the actual IFC file. Now in this particular example, what we're going to do is we're going to go looking for a specific beam. But if you wanted to do it otherwise, you could just click on a beam. Okay. Zoom into it if that was the beam you were looking at. If you knew that was, you can click on that, for instance, which is the top node. And then if you click this option here that says keep selection isolated, there you go. It literally just isolates everything else. So it's a nice easy way of just clicking on something if you know that's exactly what you want. Okay. But let's turn it all back on again. Right, so we're going to look for a specific element. Okay, so if in this example I know that it's an IFC beam, I know the property I'm looking for is called tag, and I know the tag number is 3310. So if I now add to selection, you can see here, because I've got keep selection isolated, it's actually hidden everything else. If I untick that, it will come back on. Okay. If I hit zoom to, it will then zoom to that object. So now the center of the zoom is the object that I want it to be, is that I zoom to. So I click on that object there. We then can scroll down and you can see the tag property is indeed 3310. But it's not, that's just one part of the beam, the top part is another, and the bottom part is another, and all these fastenings are another. So if I actually click on that object at the top there that says CG3_W, and then just hit the keep selection isolated option again, there we go, you just have it on its own. And I think that's what we need for this example. Now we can compare to IFC files. With that done like that, I could hit export and it'll just create an IFC for just that. But it's actually going to be easier to click on this and actually digitize points if it's essentially committed to ordinary triangles. So that's what we're going to do. It'll also be useful if we ever encounter the scenario where we need to sort of match lots of beams to lots of other beams scanned in, shall we say, a warehouse. Because actually what we can do is we can copy the model of the triangles and then just repeat it wherever we need to place it on top of a point cloud. So that's what we're going to do for now. So I'm going to hit commit triangles. It offers us a name, so I'm just going to call this one, say, beam template, and then just press OK. All right, so let's right click everything now. I'm going to remove the IFC from the view, close this one down, close the model down, and I've now got one called beam template. Okay, and if I were to double click that, it will show us it in the 2D view. These little outlines here are actually the contours because I don't think it's flat. And if I go to 3D, there you go, we can see it. Okay, so we're going to use this and digitize points on it so that we can then move or transform it or transform the point cloud into the same coordinate space as this. Now when it comes to digitizing, we need to make sure we pick exactly the point that we want. And the easiest way to do that is to code the points, because then they'll be drawn in the view. So if I click on points here and put that, say, into wireframe, we don't actually see any nodes. Okay, so for us to actually digitize physical points or lock onto the physical points of this, I need the 3D view to see them as survey points. So what I'm going to do is I'm going to very quickly jump back into the model. I'll go to settings, I'll go to codes, and I'm just going to come down to a code, say spot level. I'm going to add, and we'll just call this one node for argument's sake, and we'll just call this one an IFC node. Having done that, I will change it to color so it's easy to see. Let's call that red. Okay, okay. If I go back into the spreadsheet view, select all those and recode to node, what should happen is when I refresh the 3D view, there you go. We've got nodes everywhere because it knows how to draw them. The code is telling the view how to draw it. I probably just need to change things a little bit so the nodes aren't quite so big. So let's say, I don't know, 10 for the size of the point, maybe 2 for the wire, for the thickness. Right, so I now have some points. Okay, and what I'm going to do is I'm going to digitize over these points. Okay, so that I've got a series of control points that I can then digitize the same points on the point cloud data and then hopefully create a nice transformation to go from one to the other. So to start that process, I'm going to go to digitize, and in here I'm just going to say SL for now. So you can use any code you like. I'm just going to use a code that draws a point. I should probably use a point that is easier to see for the benefit of this demo. So let's go back to the settings, go into codes, and let's go down to spot level, and let's just make that yellow. Alright, and then just refresh the view so it sees that change. Now, if I digitize in SL, hopefully I'll get yellow points. So we'll go to digitize, SL is our code, I'm going to hit select points. The point number is important, but we'll set those when we finished in case I make any mistakes. So for now, I'm just going to leave it as SL, and we are making sure that our lock mode is set to DTM point, because then it cannot lock to anything else. Right, so I'm going to start clicking that point there. Okay, notice it can't click anything else apart from a point, so I'll go from that to that, and I'll come up to here, click that corner, that corner. Alright, so that's one of the tops of, that's one part of the top of the beam. Now to control the rotation, I will also do the same down below. So we'll click on that point there, and that point there, and that point there, and then right click. Okay, now because I've got points on top of points, it's difficult to see them. So if I actually tick always visible here, you can see I actually do have my yellow points where I want them. Having done that, what we're going to do is we're going to repeat that process, but do that for the point cloud. If I scroll down to the bottom of the listing here you can see our spot levels. So before I forget, I'm just going to renumber these points, and I'm going to put a prefix of ST on them, just so I know these are the points I need to use later on. Right, so now I need to create a new model because this is going to handle the point cloud. So we'll just call this one beam scan for now. Double click on that to go into the 3D view for that one. And then I'm going to just drag and drop the LAS file in. It's so small it loads almost instantly. Okay, so here we have our LAS data. Now the first thing I do is I'm just going to do a little bit of noise removal. You don't have to do this. This is just demonstrating it's possible, I suppose. So I'm going to add group, a group called noise, and we're going to go to tools, and we're going to use the noise filter. My target group is going to be noise, and I'm just going to use the near neighbor approach, and we don't need to worry about de-densifying. So I've done this a few times just to play with the numbers. If you make a mistake, you can just essentially hit remove on the noise group. It'll put it all back into the top group, and then just repeat the process. So pick the noise group and then change the settings accordingly. But for this particular scan, I found that one point within 15 mil seems to work reasonably well. So if I press apply on that, it's found 6,000 points. But if I turn those off, you can see it's not being too aggressive. Okay, so it's just removed a little bit of the fuzz, but it hasn't taken out, huge chunks of the data. That's before and that's after. Now we have a couple of ways of proceeding now. We can either move the point cloud to where the beam is, or we can move the beam to where the point cloud is. All right. If we're just doing one, then I guess it doesn't really matter. But if we've got a warehouse of scanned beams like this, then we'd need to use the second approach and then copy the model and essentially move each individual copy of that beam to its location of the appropriate scan. So you might want to group up these individual beams into individual groups so that you can easily segment the point cloud for later on. But for now, I'm just going to start off by doing the most, shall we say, easy way, which is essentially just to click points in the point cloud and transform that to the location of the 3D model. So we'll start again in the same way. So I'm going to go to digitize. I'm going to use the code SL. Okay, hit select. Now then, this is very important that we click on the appropriate point. We have to do exact points. We have to make sure we click exactly the same points in here to the points that we clicked on in the 3D model. So I'll make my lock mode point cloud. Okay, now if you control click on something, it'll zoom to it. Okay, but there comes a point where you can't roll a ball any closer. So if you hold down control, you can actually push through that, and you can now click the points you want. So there's my first point. I'm going to hold down control, click on there, and do the same. Hold down control and roll a ball and say push to that point, and repeat for the other points. Control to push in. Okay, now the problem with this is obviously that I need a point here, right? I cannot click on empty space, right? I need a point to actually click on. All right, so oops, I haven't got my points turned on, so let's turn my points on. There you go. So there you can see. So there's a point, there's a point, and the same will be true down here. So if you need to tweak these points, you can go to editing and you can go move point. So if you need to nudge the points, you could choose to lock the plan position and change the height, or lock the height and change the plan position, or just move the point. It's entirely up to you. But obviously these points need to be as close as possible to where they need to be. As I said before, we can only click on a point if it exists. That's not entirely true, because if we cheat and use a section, we can actually click on the plane of the section. So for the bottom points, I'm going to do it using a section. So if we go to sections, and we will choose a section from 3 points. Okay, so all we have to do here is click points that actually exist on the surface that we want. All right, not the corners, just the surface. So I'll put a point there, and then we'll come all the way around to the other side of the beam. Control click, and point, shall we say, there. Okay, now it's very important you say no to this. We do not want to snap it to the horizontal. So you say no, we need to leave it where it is. Let's make sure I can see it. So if I tick on show path, so that's what the section is looking like at the moment. If you need to adjust its rotation to align with the beam, then you can click in this box here and then just roll a ball. Okay, to tweak that, I need to make it probably a little bit wider, so just go a meter wider. Let's make it 10 meters long, and we don't want it too thick, so let's go 0.01. Maybe even thinner than that, so that's 0.005. Okay. Now then, so we can now kind of see the beam. Okay, and when we digitize, we can actually do it in a free lock mode, so that we'd actually locked to empty space if we want to. If you need to fine adjust this, okay, so if I was to drag this, okay, it will move it. I need to get it in exactly the right spot. Remember, I'm trying to get exactly the same spots that we digitized earlier. Click to cancel what that's doing. So yeah, you can manually drag it up, okay, or you could say change the interval here. So if I go into here and enter 1 mil, and then say just click in this view, and if I use greater than and less than, I can actually nudge it by a millimeter. So you can be very precise about how you clip the view. Okay, so hopefully that's now aligned with the data. If you tick lock section, then you can move this view without worrying about the actual section moving as well. So on close examination, I'm not happy that this section is actually sitting correctly on the plane that I want it to. So I'm going to delete it and restart that process. We'll delete that plane and we'll repeat it. I'm going to make my pick precision medium, so I'm making absolutely sure I'm not picking a point behind a point. Pick mode is nearest. Yeah. Okay, so let's try that again. So pick a point here. there, there, say. No, to making it horizontal, I will need to rotate this. Okay, and let's make it longer. Okay, the section is locked, so I can't accidentally drag it. And my nudge is set to 1mm, which is good. You can also use snap to point, so you can click the point that you want it to snap to. We can do clip main view as well, so that we can get an idea of what's actually on the plane of the section. I'm much happier with that plane. I think that's sat on it properly now. So we need to make sure, I think when we digitize it, we have the pick precision set to medium, so we don't pick a point behind where we think we're picking it, even though it's set to nearest. Right, so I now need to make sure I pick these points in the correct order. Okay, so I was working from lowest to highest before. So we've already done the top 4, 1, 2, 3, 4. So now I need to do the bottom 4. So if I hold down Control, you can see that I'm actually down here. Okay, that's where the cursor has been highlighted. I need to pick a point out here somewhere. Okay, so if I go to digitize, we'll hit select points, and I'm going to enable the free select. Okay, because then I can actually go anywhere I like. I don't have to be actually on a point. I just right click, I can gently nudge it so I can see the corner. I think that's as good as I'm going to get it, so we'll click a point here. Okay, and then point there. Come up to the top and repeat. And then cancel. Now then, I'll close the section view down, turn the section off, and just check that. That one seems to be a bit off. So I'm not happy with this corner here, so I'm actually going to tweak the position for that point. So I'll go editing, move point, click that point, and I'm just going to nudge it to there. And that one just slightly over to there. There we go. I think that's going to be better than it was before. Right. Now we need to test the transformation. So to do that, what we're going to do is we're going to go back into the spreadsheet view. I'm going to select these, renumber them, start with ST as well. Okay. So we now have hopefully the same points here as we do here. But these ones are not in the right coordinate system. Okay. So what I'm going to do is I'm going to cut these. And I'm going to put them under coordinates. We'll go new, and I'm just going to call this one IFC beam 1 for now, and paste those in. I now have the points I need where I need them, because what I'm going to do is I'm going to go right click now. I'm going to go to transform, and I'm going to go to point 3D. I'm going to click on load and load them from here. Okay, and now you see the overall errors in millimeters of each point once it's been transformed to its new coordinate system, and the general overall error here is 4 mil. So I don't think that's too bad. Obviously, if you weren't happy with that, then you might need to go back in and adjust these digitized points from the point cloud. I think that's as reasonably close as we can expect to get. So save transformation, absolutely, okay. And I'm just going to call this one IFC 1 for now. So now those points will be transformed. If I go to the 3D view, okay, and hit refresh, the points will move because they'll go to their transformed locations. We still need to transform the point cloud. So to do that, we go to point cloud tools, load transformation, and we just load that transformation there, press OK, and it instantly transforms it. Okay, so now we can see we have our points and our point cloud aligned again. We should now be able to go under home. We should now be able to go back class, and if we bring in the template, there we go. Okay, it looks like it sits exactly where we need it to. If we come out of wireframe, go to normal, come out of always visible. Okay. Obviously, you could add more control nodes if you wanted to fine tune it even more. It's up to you whether you think the transformation is acceptable. Okay, now once you've done that, once the two are aligned, you can now generate the heat map if you want to. So to do that, what we're going to do is we're going to go to Point Cloud Tools, and we're going to use the tool which is called Distance to Model. Now we need to add some bands. If you have any bands in here already, you can hit clear, just in case you've already got some set up. We'll go add bands. Add some bands based on the criteria you're worried about. Positive and negative isn't going to make much sense in this case because we've got lots of different surfaces at different angles to each other. So positive and negative isn't really going to work, I don't think, because we can't guarantee it's going to be the right side of the triangle. So I'm just going to keep it all positive for now and do it absolute. So we'll say, should we have our maximum distance, say 20 millimeters, so 0.02, and I want them at 5 mil spacings. There we go. So it reckons that there's 4 groups. So we've got less than 5 mil, between 5 and 10, 10 and 15, and 15 to 20 mil. So that's good enough. So I press OK. So we don't want it to do a vertical test, so we want that definitely turned off. We do want it to create the groups. Just want it to be absolute, so we're not worried about signing. Otherwise, obviously choose signed, and then just hit apply. If you get this error message, it's because we're using the wrong model. So I go up to beam and select the template. Now it should be able to find something to actually test it against. There we go. So now, if I were to hide the model, and now we can change from intensity to group colors. Okay, and now we've got our groups down here. Okay, so now we've got the groups created for us. We'll just tweak their colors. So let's say if I expand the 5 mil, let's say that should be green. And if I expand the 5 to 10, maybe let's try and find an orange. Okay, and then we'll go maybe to magenta, and then finally to red. Now then I've done that, if I turn off never classified, and then we can put the histogram on, and then turn on the values, you can see that 96% of that data is under 5 mil, obviously. Okay, as you can see there. If we turn everything else off and put never classified back on, and you can see there might have been the occasional bolt that's been knocked out of place. But on the whole, everything looks to be green. Everything looks to be within tolerance. Now, for this particular example, we have moved the point cloud to where the 3D model was. But what about if we have a warehouse full of beams and we need to test each one of those? So in that situation, the actual better way of doing it would be to create a copy of these individual beams and move those models to the appropriate location for each of the grouped scans. So that's what I'll now demonstrate. So to begin with, I will remove the transformation from the point cloud. And I've got my existing points here that I digitized from the beam when it was in its correct coordinate system, or as it's in its correct original system. I'm going to put them back because I cut them out, so I'll paste them in. Okay, so if I go back to the digitized points from the point cloud, these have been transformed. Okay, so if I click undo, they'll go back to their original position. These now form the position where I need to move the model to. So we're going to copy these, go up to coordinates, do new, and we'll call this one scan 1 location. Paste them in there. Okay, so now what we're going to do is we're going to take our beam template. We're actually going to copy it. So I'll take beam template and I'll call this one just beam 1 copy for now. That's what we'll use. So now we've got our original and we've got the copy. Scroll down to the bottom select those points, right click, go to transform, same again, point 3D, load, and this time we're going to load scan one location. Okay, now as before, the error is 4 mil because it's the same transformation, just essentially done in reverse. We'll say OK to that. I'll call this one beam 1 to scan. So now, if I view this one, zoom to extent, obviously get rid of the heights, go to 3D, make it normal. Okay. Hopefully, if I go to load the point cloud, there we go. Obviously, it's still got its groups in here. So if you wanted to repeat this again, but doing it the other way around, you just merge your groups, which essentially get rid of all of these and put everything into the top group and then just repeat the process. Okay. But in this situation, we've moved the model to where the scan is. So if you had lots of individual scans, i.e. in their own little groups or whatever, you can obviously accommodate lots of individual beams across a warehouse this way, rather than doing it the other way where we are moving the scan to the beam locations. And that concludes this little tutorial.